This conference will now be recorded.
And we're gonna go over some things. Here's the agenda for today, right? So we're gonna talk about what is cloud native. We're going to ask or interrogate the question presented, why would you even want to adopt the cloud native architecture in the first place? What does declarative mean? And we're going to look at how declarative APIs manifest themselves in each step of your path to being cloud native. And then I'll give you some cloud native resources and we can have an open discussion. I hope that sounds good to everybody. And also, I didn't know if we make this interactive or not, Tamika, but I'm fine with just answering questions as we go along because I don't know, some things might just pop out to people.
Yeah,
hopefully, go ahead.
We're usually interactive. Again, same rules for the meetup. If you want to post something inside of the chat, that's fine. If you don't want to talk, but if you want to hop in and ask your questions, feel free. Try not to hold on too long to your questions so you don't forget them.
Okay. Yep. And hopefully you walk away with an understanding of the benefits realized with the Declarative API Cloud Native principle. All right. So what is Cloud Native? Well, Cloud Native is immutable infrastructure, microservices, and declarative APIs. And the CNCF defines cloud native, as you see on your screen, as a little bit more than that, but it's basically those three things to keep it simple. Today, I'm going to be talking about the cloud native APIs specifically. So in order to think about the cloud native principles altogether, a little bit of a higher level overview in the way that I like to think about it. There was a programming or an influential paper that was written in 1972, I believe, or 1975, called Programming in the Large versus Programming in the Small by Frank de Rimmer. And it kind of went over a problem that's really been plaguing programming for over 40 years. And that's figuring out how to reason about, define, and direct several programs, components, or modules as a system. When we look at the cloud native principles as a whole, it's analogous to reasoning about programming in the large. But the various domains of cloud native architecture, like containerization, CI/CD, orchestration, observability, so on and so forth, can be associated with programming in the small. And some aspects of the former can be found in the latter. So cloud native is really a set of principles, and just at a high level, the cloud native in the large is a way to connect systems using those principles. Cloud native in the small is a way to develop applications using those principles. So when we're going back and forth and trying to reason about this, it's helpful to me to think about it that way. So why adopt cloud native architecture in the first place? I think a good place to start here is with anti-fragility. Anti-fragility is when a system gets stronger rather than weaker under stress. The term was popularized by Nassim Taleb in his book of the same name. An example of anti-fragility would be the immune system in humans. Certain types of exposure to illness actually can make the immune system stronger and more resistant to stress. So cloud native architectures are a way to achieve resilience through enforcing self-healing configuration, with the best examples just avoiding human intervention altogether. So you have these systems that don't require anything to be done to them by humans. So as far as anti-fragility, if anyone has any questions, go ahead and just put them in the, I guess, the chat, and maybe Tamika read them out. So we can, as far as DevOps and its relations to cloud native, DevOps historically has tried to address certain pains in the data center. Okay. Example, one of the pains being Snowflake servers, special servers that cannot be modified without great fear because no one knows how they work. Cloud native architectures try to address this lack of reproducibility with enforcing configuration that is declarative, which is different than the server synchronization models of the past. If you're familiar with the older, I don't want to say just older, because people still use them, but the alternative ways like Chef and Puppet. Because cloud native architecture configuration is declarative, it also lends itself to performance and availability through enforcing configuration that's easier to scale out versus having to scale up. So, all right. Are there questions there?
Yeah, one was about the slides.
Okay, yeah, I'll make them available.
Okay.
Uh-oh. Now I have this chat just in my way. All right. All right, so what does declarative mean? Declarative says, or declarative in configuration says what to do, but not how to do it. Imperative configuration is a set of commands which say how to do something, and they're usually in a series of steps. I'm going to give some examples of declarative programming, and then I'm going to go into declarative with respect to infrastructure and the reconciler pattern. All right. Declarative programming languages have been around for a long time. SQL and Prolog are examples of declarative languages that are almost 50 years old. A user declares a query in pure SQL that retrieves, updates, or deletes data from the database, but the user does not say how to do those CRUD operations using a series of steps or loops. So the user doesn't say what the implementation is. An example is over here on the left, the select star from customer where last name equals Smith. It doesn't say, how to go into a table and loop through each record or anything like that looking for Smith. Prolog is more of an esoteric but influential language that it's a logic programming language that's declarative. And the user Prolog declares facts and rules and then queries the system without specifying any implementation. So we have 3 facts on the screen here. You have John plays piano, you've got Susan plays piano, and you've got Mike who plays video games. And then you've got a rule there that says essentially people that want to hang out, they got to play the same thing, play with the same activity. So then you can query. So can John hang out with Susan? And the answer is true. Can John hang out with Mike? The answer is false. So that would be facts, rules, and then querying, but no implementation. And the system infers the answers. You can do some pretty amazing things in logic programming. So, but there's no implementation, and that brings us to declarative with respect to infrastructure. So within cloud native infrastructure, declarative configuration is implemented using the reconciler pattern. Within the reconciler pattern, there's a desired state of the system, which would be some representation of the declarative configuration files. And then there is the actual state, which is a result of querying the system. The pattern gets its name from repeatedly querying the actual state of the system, and then when there's a difference between the actual state and the desired state, it reconciles the two by applying the desired state. An interesting note here is that even if configuration is not declarative, if it's at least idempotent, then the desired state can still be reached. Let's see here. I think I see some questions. Is reconciler like idempotent? Idempotent means, oh, someone answered it. Okay. That idempotent means being able to reapply either some command or some action, and then without there being a side effect. That's the pure definition. Sometimes people can come up with examples where there are side effects, but that's really the thing. We really, the reason why you want to do or have idempotent, say, scripts, a good practice for DevOps scripting is to have your scripts be idempotent so they can be applied repeatedly and bring the server back. This is out without considering the reconciler pattern. This is just best practices to be able to bring the server or whatever resource you're applying script to back to a certain state. You don't have to worry about preparing the server or whatever resource before you apply the script, so it's safe. All right, I think this chat went over. All right, so now we've got Kubernetes as a reconciler. Kubernetes is an implementation of the reconciler pattern, which uses an application's declarative configuration specified in YAML files. The options for an application, such as how many instances of pods and containers, and how those instances are monitored, such as using the liveness and readiness options, they're kept in the Kubernetes manifest, which is queryable from the Kubernetes API. More fine-grained customizations can be provided with custom resource definitions, which store and retrieve structured data. Then you also have custom controllers, which read the desired state and then maintain the desired state. And then you have operators, which are a combination of the CRDs and the custom controllers. So with those three, really the CRDs and the controllers, those are really the building blocks for the reconciler pattern, right? And then the operator is like really what within the Kubernetes as reconciler, Kubernetes as declarative APIs, so on and so forth. That's really what the ultimate declarative API is supposed to be. So, and then, you know, as far as representing all this stuff, the application and infrastructure developers targeting Kubernetes, they often use Helm charts to specify the declarations. So you have over on the right here a liveness probe. So what is that? The liveness or readiness probes basically, you have an application and then you want the reconciler, the orchestrator, right? You want it to be able to restart the application whenever something is not working. So liveness says, okay, you know, responds whether it's working or not. So and then in this example, we're talking about a web application. It does an HTTP GET to the health's endpoint on port 10.254. And if that comes back with the 200, it's going to say, okay, everything's great. If it comes back, it doesn't come back at all, 404, whatever, it's going to restart that container or that pod Readiness probe is kind of similar, but basically that gives the go-ahead to start sending or forwarding traffic to the resource, to the application. Does anybody have any questions? All right, somebody posed. Okay, good. And that brings us to declarative APIs in the small. So having seen what declarative APIs are in the large, and then drilling down into the orchestration part of cloud native architecture, we can now take declarative configuration and look at how it applies to other parts of an organization's path to cloud native architecture. Declarative APIs in the small are work in progress, but there's some examples here on how declarative APIs have been used in the CNCFs, which is Cloud Native Computing Foundation's trail map to cloud native. Over here on the right, the trail map is actually bigger than this. I think it's maybe 11 steps or something, but I have the link in the slides for you to look. This is basically a way for an organization to become more and more cloud native. So containerization, you got CI/CD, then you got orchestration, which is Kubernetes, so on and so forth. And then you have other things. So on the CI/CD step 2, how would you make that or use declarative APIs within that phase? There's a project called Tecton. It's a CI/CD tool that has Kubernetes resources as a first-class citizen. It actually uses Kubernetes to implement the tasks and the jobs and so on and so forth. The Tecton Triggers project responds to external stimulus, like say an event, so a webhook or something like that, and attempts to change the project it manages into a built state. Right, custom operators could be written to observe the actual state of other pipelines and respond accordingly. That's something that we're looking into to try to have distributed pipelines across multiple CD tools, which is just a serious issue. Within orchestration, of course, you've got Kubernetes, but you also have something called Cluster API, right? So we've seen that Kubernetes manages applications by reconciling the actual state of the application with the desired state of the application. Well, Cluster API reconciles the state of your actual nodes. So that's either metal or virtual nodes with a desired state. And it bootstraps Kubernetes using Kubernetes. So it's that, well, how do you get Kubernetes installed in the first place? And then does it monitor the nodes? Kubernetes actually doesn't monitor your nodes at all. So you have to figure out what you want to do if a node goes down. If you're on the metal, all of the service providers, if you have a Kubernetes offering on Amazon or Google, they actually have some type of monitoring that goes on with their nodes. So you don't have to do that. But if you're going to be on the metal, then you're going to have to do it somehow. And Cluster API gives you the tools to be able to do it. It won't do it right out the box. So it's on its way. So, all right, so now you have observability. And Prometheus, it's a cloud native metrics and monitoring solution with multiple moving parts. Prometheus operator installs and manages all of the Prometheus components based on your desired attributes. So if you have multiple, let's say you have 7 different things to install for any application, the idea or one of the core concepts of cloud native is to really automate, try to really have everything completely automated to the point to where the system actually can, if something goes down, it can heal itself. Well, an operator is made like what we talked about earlier. You use CRDs, which manages the data, right? And then you use the controllers, which is going to maintain the state, the active state and desired, and look at the desired state, active state. Both of those together, you use that to create an operator. Then you can do things to install complicated projects, with seven components. So Prometheus, in order to get all the different components installed, there's dashboards, so on and so forth. You can use an operator to try to get it all installed and to make sure it stays installed. You can also even, like, it tries to go out there and see different nodes and try to collect metrics automatically on certain pieces, on different pods, I should say, and nodes actually. So that's an operator, and again, reconciler pattern. You've got Envoy, which to talk about service meshes a bit. Service meshes handle layer 3 to layer 7 networking challenges such as service discovery and ingress and egress retries, and proxying, load balancing, and other things. Envoy is a cloud native service mesh, which also has an operator project, right? And then again, installs and manages all your Envoy components based on your desired attributes. Envoy is a very, very popular project. And then you have networking. So a project that I'm involved with, the network service mesh, it addresses specialized networking layer 2 and layer 3 use cases, typically desired by telecommunications companies. The NSM operator project, yet another example of using desired state to manage the installation. But here's probably a better example of declarative APIs within networking. It's somewhat, complicated, but worth talking about. NSM internally tries to encourage network operators to design their network services declaratively by declaring their preferred local mechanisms, right? A local mechanism would be a Linux interface, so a network card, right? But there's other ways to connect. So direct memory interfaces, say like MEMIF. So that's creating a network connection through memory, not through an interface card. And vhost user and some other ways to connect. When you make what's called a network function or network service, you can say, all right, I have the capability of connecting over a MEMIF or memory. Why is that useful? Well, if you're on the same machine, you don't want to go all the way out to the regular network cards and all that. You can go straight over memory and connect to all of the other containers on the same node. So this is one of the drawbacks of, let's say, microservices, where people say there's too much traffic in between them, between the processes of the containers, pods. It has to go all the way out to the network. Well, actually, there are ways to make it to where you're actually communicating over memory. So it would be kind of similar to being communicated between processes in traditional programming. So with doing all of that, the NSM manager implements the desired state and does like what we're saying, uses Kubernetes to make everything reconcile. It also encourages higher levels of abstraction for network services. For example, traditionally within development, you may, when you're having to set up your service, you may, as a programmer, which is what I traditionally am, you may end up having to fool around with some networking, some subnet. Someone says, hey, make sure that your service is available over this subnet. Well, that's network service mesh kind of discourages that type of configuration. It basically says what we were saying before, say what you want and not how you want. And some of those, I guess, subnet masking is an example of something where they would say that's a little bit too imperative. So that's specific to networking, maybe a little bit too much. But let's see, somebody had a question here. Is Prometheus the sole metric solution for cloud native? No, it is not, but it is the most popular one. There's there's some other ones, and then here's the thing. So you said metric specifically. So there's also tracing, which would be, I want to say, Jaeger, and then there's other ones, and I'm forgetting what they are right now. But there's a whole slew, and actually, oh whoops, there's some on this list here, which I can't see because everything's in the way. Okay, right, FluentD and some of these other ones, but basically, as far as observability and let's say tracing and metrics, so on and so forth, you have a bunch of options, but the CNCF, they try to make it to where they're all what they call open telemetry compatible. So there's an open metric standard, but I don't remember of one of the other projects that are open metric standard other than Prometheus. They actually create the open metric standard. Let's see here. Lost. So let's go ahead and go to the conclusion. Actually, declarative APIs. Let's. I guess they're a way to express configuration, and they're used in conjunction with a reconciler pattern. And they implement a self-healing system. And when adopting cloud native principles, you can use that the trail map as a guide to help you on your journey. Each step in the path can also adopt cloud native principles with varying degrees of maturity. And declarative APIs are one of those principles. And I hope I made it somewhat clear on what the declarative APIs are today. But now let's go to the open discussion.
So what I did post is inside of the chat, I posted the cloud native landscape. Just don't let all the tools on there overwhelm you, but just, just take into consideration, like, hey, if you're looking at Prometheus, what are your other options? Some may not be as popular, but there are other options when you're looking at that.
Yeah. All right.
So I did have a question though. When we're thinking about cloud native, right? And you're saying, hey, I built this out in AWS. Does that automatically make it cloud native if you just built an application out in AWS? Like, what if someone had to take away, if they had to determine if something was cloud native, what would be your steps for that?
Okay, so the steps basically, oftentimes you said you use AWS. That's not even saying you're using containers, even at that point, so that would be even beyond this path that I'm showing on the screen here. A lot of times, so no, it wouldn't be cloud native. A lot of times people think if they put stuff in containers, then they're cloud native. And then even that is really not the case. So you really probably need to be all the way down on this path if you want to call yourself cloud native, you probably want to be all the way down to level 3. So you need to have containers, you need to have some kind of CI/CD, right? You're not out there manually putting the commands into Kubernetes to install your application, right? And then you can have Kubernetes with Helm charts, right? Hopefully you're using some way to communicate to Kubernetes other than hand-rolled scripts for your application installation. At that point, you're starting to be where everybody else is. Then you start getting into where, let's say, people that have a bunch of different orgs within an enterprise, let's say, that have different microservices that have to communicate, then they have so much pain with being able to manage the production, they need to have some type of observability, so they have tracing and metrics and so on and so forth. But after that, you've got service proxies, service meshes and all that. So why would you even want to do that? Well, I like Envoy's story with that. So Envoy comes out of Lyft, and they, as of maybe even just a year ago, they were not even using Kubernetes. They built Envoy. And well, how does that replace Kubernetes, or how can that help you to do that? Well, basically, they started out Python shop, PHP shop. So they start having multiple different applications, different organizations that are making services, and they're trying to communicate different languages, and everyone's scared to put stuff into production because they don't know what broke and who broke who. So they started writing Envoy. The very first thing that they did with Envoy is retries, right? So basically, if you've done any development, and let's say you do a call to, whatever, GitHub or something like that, and you want to see how many people, or if it's time to do another build or whatever it is that you want to do, you call some API, and then you do some process after you do the call. Well, when you do that call, it can fail, and then you fail, right? And that call, you can have maybe 4, 5, 6, 20 calls, 100 calls or something inside of your service, and that's all dependent on someone else, some other service. It could be external to your organization, but it's really painful when it's internal to the organization, because normally those aren't built to that level of scale. Everyone's not looking at it yet. But then when you wrote that service, it looks like you failed. You don't know why. Well, Envoy was built to handle that. When you do your call, it's essentially Envoy, I'll just say, intercepts it, and then it does the retry. And then it does the retry, and it does it in a smart way where it backs off. If it'll try a couple times in a second, and it'll back off and go slower and slower up to 10 seconds, and it'll stop. And that was the beginning of Envoy as a service proxy. And then they made it to where it can reroute traffic. They did a bunch of different things. They also put in some observability. There's observability built right into Envoy. You can take a look at across your organization and see where all your hotspots are and what's failing. That kind of, and that makes Lyft be a real enterprise that does microservices right. They didn't do any reconciliation. When their nodes would go down or servers go down, they just reroute around it and say, oh, well, that thing is acting bad, don't go there. And then they would go out and either manually restore, they'd go investigate why it failed, but it still worked for them. But you use something like an Envoy in conjunction with a Kubernetes, you're really on your road to really being really resilient, self-healing, and all that. But I don't know if that answered your question.
Yeah, it did. I just want to make sure that we understand what when we say that we're cloud native. Hey, I deployed into AWS. Oh, I'm officially cloud native, right? So I just want to make sure that we walk away with a clear definition of what that actually means.
Yeah, it's definitely not. You definitely need more. Immutable infrastructure, so that the easy way to think about that is you have artifacts that are created by your build system, your continuous delivery system, right? You have binaries or so on and so forth, whatever it is that you are going to deploy and put on in some environment. Those cannot be changed after they're deployed. You replace them completely, right? So now you essentially are going to you're going to use a container to do that, right? So that would be more technical, based on whatever technology you're using. You can actually do, well, our argument is that you can do cloud native without Kubernetes, without containers, without any of these things. In theory, you can do it with any technology. It's just the principles, they're generic, but containers are very coarse-grained, small, and we know how to deploy them. They're fast, and those are the properties that you want with the something that's going to be orchestrated. So you want your binary. Before, for me, growing up, binaries were binaries, little executables. Now, your artifacts, binaries, where they're containers. So that you don't want to, as far as immutable infrastructure, you don't want that someone going out there going into the binary and changing it, and at runtime is not acceptable. So you basically, the way that you're deploying, you're using Phoenix deploys, so on and so forth. So yeah, I don't know if that answered your question.
Yep. And another one that you just brought up, I just want to make sure we get definitions and things taken care of. I always find conversations like this beneficial for a number of reasons. One, so that when you're in conversations at work or when you're talking to people, you have a clear definition, and you have resources where you can point people to and resources that you can utilize yourself. So you mentioned in that particular statement that you just had, mutable infrastructure versus immutable infrastructure. Is everybody here familiar with those two terms, or at least understand that? And if you don't want to say anything, you just type it in chat. But if you want to give a brief, I guess, I don't know, one sentence on mutable and then one sentence on immutable, if you can.
Yeah, it really is. Artifacts modifiable in place versus not. The immutable infrastructure, your artifacts are not modifiable in place. So there's no human going out there changing the binaries, right? So that's really what it is. So Kubernetes, the process, whatever technology you're going to use, it's going to start up, right? They call it, a Phoenix deploy. It's going to start up a brand new process, right? With the brand new binary. The old one's still chugging along. It's serving users, has connections, whatever. That one's still chugging along. But all new traffic is going to go to the new process, the new artifact binary, right? And so that's how the immutable infrastructure has to work, right? So there's arguments it's not even really a blue-green deploy, right? With the blue-green deploy, you have a server and you repurpose it. The purists, the cloud native, they say, no, we don't even like that. We want it to be Phoenix. So there's that. But then another thing to think about, what was very confusing to me, was when we say immutable infrastructure, how far does that go? Really within the community, they're talking about above Kubernetes, so applications, right? So the applications, I thought that was weird, like applications aren't infrastructure. So why do we call it immutable infrastructure? Well, if you have an orchestrator, they're calling that the capability to make your applications immutable. Now, having said that, you can make your nodes and things below Kubernetes immutable as well. There are operating systems and deployment methods. Cluster API would have some tools that allow you to try to start doing that, but most people don't do that yet, right? So that part is still being developed. So when people say immutable infrastructure, oftentimes they say they want to play like the nodes are immutable, but we're still playing around with doing what you would call server synchronization on the nodes. So basically, some of the more popular ways to install Kubernetes is still using Ansible, which is server synchronization.
Oh yeah, good old Ansible.
Yeah.
Did anyone have any other questions? You know, I can keep going. I don't want to hog up the the Q&A. Now on this, can you go back to the trail map, please?
Yeah.
Now I've actually presented this in our talk, and this may just be getting outside of the scope of declarative APIs and cloud native. So this is a conversation we had. I don't know. I think we did an agile talk on this. And so looking on this in this meetup, we did an agile talk. So looking over this, when I'm looking through notes and reading about things, agile comes up and cloud native comes up all at the same time. It's yeah. And so can you speak, because I know we've had conversations about agile. Can you speak more on the presentation of like if you had to present this to someone, this trail map about agile and cloud native and how they all are intertwined with each other when we're talking about this in teams and even as providing solutions to problems?
Yeah. So there's a couple of ways to go into that, but I would really focus on that second stage, the CI/CD portion and its relationship with Agile. The continuous delivery portion. So with Agile, you're really trying to have, sprints, and you're trying to, many people's sprints are every 2 weeks, I don't know, every month or whatever. So what you want rapid deployments, and you want to be able to roll back things, so on and so forth. That continuous delivery portion and making it to where you have a strong pipeline, the ability to push things out, create artifacts and store them, sign them, whatever it is that you need to do, and make it to where that no humans have to actually get on the production box. That's your gold standard, right? It should be all modifications to production or really any environment should be done through the pipeline. And then here's another thing about Agile. So if I want to work on a project or someone else's branch or something, some ticket within Agile, a blocker is being able to get the environment for that specific branch. It could be a bug that's in production. It could be or something else. Having a strong pipeline is going to make it to where you can create not just the production environment, but you should be able to create any environment. That's the whole idea with continuous delivery. You should be able to deliver an environment for some developer so that they can experiment or work, quickly. And then that goes into the properties of Agile, being able to move with agility, with speed, and respond to things that happen. I think some of the things where people kind of, where cloud native is analogous with agile, like agile is about responding to stimulus, responding to external events in the world, and cloud native is about responding, right? That agility concept, I'm sorry, the anti-fragility concept, right? Self-healing. So the system actually sees that, oh, this pod is having problems, restart it. It's not going to wait for some operator to come by and do anything. It's going to do it. So that there's analogies there. And so it kind of seems like that, but then that's where you need the observability to say, okay, well, why is this thing restarting all the time? And then you can try to make it to where it's more stable. Does that answer?
Yep. Yep. I just wanted to bridge that gap that we had. And for those that are new, we actually did a overview of Agile, kind of like an Agile 101. We're probably gonna do another one. That's actually, I don't know, D, is that up on YouTube yet? I'm not sure, but we covered what are the different terms in terms of Agile, safe Agile framework, where does it come from, where some people are doing Agile and waterfall, where some people are waterfall still when they think they're actually doing Agile. Very long topic on what that meant, and the reason why we were doing that is because we were on a road to getting just certification, and if not even certification, just really information on understanding sprints and Scrum and Scrum Master and product owners and arts, agile release trains, and understanding what that landscape looks like, especially when you're new going into a company or your company is making a switch and they're saying, hey, we're gonna adopt safe Agile versus Agile. You just want people to have knowledge of what that actually means and what does that look like in terms of the different positions and the roles that are played, like who's the product owner and what their actually role actually is, and how to calculate your points in a sprint and user stories and so forth and epics. So that was very, very helpful for people to have that knowledge, so that way when you're walking into a company, you don't sit back and like, well, I have no clue what they're talking about. Because this actually happens. This actually happens all the time. People are like, hey, we're gonna do Agile, and you're like, oh, okay. And we're gonna deploy Kubernetes and we're gonna do CI/CD, and you have no clue what that actually means. And you don't even know if they're doing it right.
Yeah, they're not. Yeah, given some of the things you just said, the microservices, which could be its own talk, obviously, but it's another principle of cloud native. So the microservice principle, it's essentially, there's most people, when they think of microservices, they think of containers, and they think of one process per container. So it's like technology-based definition. That's a lower bound for the definition of microservice. Really, the upper bound, which is going to be tied in with Agile, is the if you have an organization, right? So a team, and I'm saying organization. If you have a team, the rate of change for the project, the rate of change is going to be based off the team, right? And so you're going to kind of move from the traditional type of team, which it's like, say, just all developers and maybe a business analyst, to the type of team that's going to be a product-based team. So you try to have everyone that's needed to manage that or those business requirements, all the way from gathering them all the way to deployment. And so they're responsible the whole way. So with that, And this ties into having pipelines and so on and so forth. But with that, now you have the concept of one team, when they're interfacing with another team, they're not going to be committing code. Maybe they're having that boundary between teams where they're having to submit pull requests and all of these things. But the way that they communicate, it's probably going to be through something that looks like a microservice. So that upper bound there, and then now you have the capability of being able to rapidly iterate, because you're developing code based off of business requirements that's a specialty for one team, right? So you have a rate of change that's different than other teams. So it goes hand in hand with being able to iterate fast, like what you want to do with Agile. So those things go hand in hand for sure.
Anybody else have any questions? I see some comments in here. Yes, it is. Estimating the size is actually hard, and the point calculations are so random. They are. And I posted in Slack about asynchronous, what was it? Asynchronous Agile. Where basically we had a discussion about going down, to 1 week sprints versus having 2 week sprints, and what does that look like? And I think it's talent dependent on the team to get from one end to the other one. And you mentioned about using Ansible to deploy Kubernetes. Well, within all of this too, what I didn't hear you mention was test-driven deployment. When we're talking about this, where does testing come into the cloud native perspective?
So as far as there's, like I said, with the pipelines, so with your continuous delivery pipeline, there's multiple phases. The first phase would be your unit testing. So the tests that the developer writes that are more fine-grained, those are applied in that first phase. And then there's a second phase, which is the integration testing. So the component that the developer writes, it's going to be tested against other components that it uses. Normally they have this thing called the test pyramid, where you have integration tests at the top, which usually take a long time to run, and you probably do less of those, but they're very valuable, and they're kind of maybe happy paths for business cases. And then the unit tests are going to be on the smaller components of the system. But that's the integration test happens at the second phase of a pipeline, traditionally is like defined by Jess Hubble in the continuous delivery book. And then you have another phase, which is you can have a manual phase where you have the humans take a look, whether they call it that a gate, where you create a test environment and you put the artifacts in there. Now they've already been tested, so the integration tests have run, and the unit tests have definitely run. And then it's deployed in a test environment, and then the humans poke around if you want to do that. Or then if you want to be brave and have continuous deployment, it goes right into production. But that's really the different phases. And then putting things in different environments, so the integration test environment and then the test environment, those are actual tests of the deployment as well. You are creating a new environment. There should be no humans involved in that process. So that's that portion. Now, as far as that's for the application. As far as setting up nodes, that's infrastructure as code, and then that's totally different types of tests. You still have a pipeline for that, or you should. And you could call that in the infrastructure as code book, they call it a change management pipeline, but it's still a pipeline. And you can use something like server spec to, and this is, you know, not talking about Kubernetes at all at this point, to check the viability of whatever images that you make that you want to use to deploy, depending on what you're doing. So, so there's that. I don't know if that answers your question.
It answered my question. There is a question in the chat said, can you break down Prometheus more? We use Grafana, etc., but we are not a Kubernetes environment, multi-cloud, but more Azure. Do they have other observability tools you would recommend or for API services?
Yeah, so Fluentd for logging, Prometheus for metrics, Jaeger for tracing. The Prometheus, so the metrics, it's time series data. So you're collecting all kinds of things for all of your different nodes and applications, so on and so forth. And you're going to have to write your application to send some of that information to Prometheus. There are some, as far as a node watcher, some things that can be installed that you don't have to expose anything from your application, but the whole concept of Prometheus, because capturing data and time series data is, it can be expensive. So Prometheus, what it wants you to expose an API. And let me take a step back. One of the concepts within cloud native is that the developer is the one that knows the performance of the application. And so it pushes off the traditional responsibilities of the DevOps person to be, hey, my application is slow, fix it. Now it kind of says, well, you're going to have to expose, it moves the responsibility onto the developer, and because they're going to be the ones that should know more, instead of someone who didn't write the code trying to figure out what this code is doing in order to play with the performance, whatever. So given that, one of the things is exposing a endpoint that will send out the metrics, and the metrics are going to be in what I was saying before, open telemetry or open metric standard. Very, very, very simple standard. This gives some certain information in a timestamp, right? And then so what Prometheus does is it goes and pulls it. Instead of a push system, it'll pull it when it's time, right? And so that's how Prometheus wants to work. There are ways to try to get around that endpoint, I guess, problem with applications that are, you can call them legacy applications that don't have a metrics endpoint. But that's really the idea of Prometheus. Now we can go into, yeah, someone's talking about the pull, right? So with the tracing, that's going to be more of like your stack traces for the programmers that they're more familiar with, and trying to figure out what blew up where. And that's really useful for trying to figure out where a specific problem has been happening. And then of course your login is like your traditional login, that's for Fluentd. So all different applications, there's really no standard for how your log will look. So all the applications have different log output, but Fluentd will try to grab all of it and then allow you to search all of it. I think they use Elasticsearch or something like that. I'm not sure, but those are the three: observability, and they're really calling it open telemetry now.
Correct. one of the comments, Elizabeth, you spoke on it. You like there are too many. There's almost seems like there's too many DevOps tools, or I would say too many tools. But I can honestly say there are a lot of tools, but you don't have to use every last one of them.
Right. Yeah, knowing the trade-offs and what
Yeah.
is it like? There's non-functional requirements. So performance might be one. Well, everyone says I want performance. Well, really, do you really need, 1 million hits per second? That kind of thing. It's just you figure out what you want and what you need, and then you can move backwards from there as far as what tools you need to use or what you have to use. One of the controversies in the past year been you don't need to. Why do microservices? Why would you bother? Do a monolith. You got one team and 10 developers or something. You're all on one team. Why not just have a big fat monolith? There's no, you got it can be fast. Everybody knows the code base. So why even bother? And it's a strong argument. You probably don't need to. You can do like what we've been doing for 15 years plus. Write all the different, get all the same properties that you would get from orchestration or whatever. Put out there some type of process monitor and all these things, and then have it to where your system behaves or tries to self-heal through all these other more traditional ways, and then have it be a monolith, right? So you don't have to adopt these properties, but it's based off of if you have a bigger team or multiple teams, different a good phrase to remember is rates of change. If you have different rates of change, those whatever it is that you're looking at, they should be isolated. Different layers, different teams, different whatever. And then at that point, the different teams, you're doing microservices, and now you've got a whole bunch of problems. Are you going to make both teams use the same language? Right? Oh, well, maybe one of those teams, they don't have to listen to you. Or maybe one of those teams, they're not even one inside your org. Now you've got all types of issues there. So now you've come into the world where it's like you need to use some of these tools on cloud native.
Another thing, someone was bringing this up about the open telemetry. Datadog. Datadog has the ability to do part of that, and I posted that testing triad, where you're testing out the UI, and inside of that, it's called synthetic, is what it is, and basically you get in Datadog you get an application key and an API key, and then you set up your tests based upon what you want. So if you want to test the drop-down menu or whatnot, you're still writing those tests, but now you can do two things. You can use Datadog API calls, or you can install a Docker container, which is just it's just a Node.js container onto your system, and then you can use that to make the API calls back out. So it works in two different ways. But I say that to say, when you're walking through and trying to analyze these different tools, and if you should use Datadog or if you should use some other tool or whatnot, be very cognizant of, one, cost, two, the logs that you're going to generate, because you're paying for that. And and then the other one is, does it work in a hybrid model? In other words, so I'm on the federal side, I'm on the government side, so I don't have a way to get back out to talk to Datadog. All right, so I have to be mindful of, can this work in two environments when I'm looking at these things? So understand, what you're analyzing, so that way you can have these takeaways and have those dialogues with your team members, and when you're reaching and contacting these particular vendors, asking the right questions and understanding what your end goal is and being very clear about that. So I just want to put that out there when you're looking at this. Not everybody can reach back out. And in some cases, some people don't want to reach back out.
Mhm. Yeah.
I think there are some questions. Oh yeah. And Mario went on to explain more about Prometheus. Did anybody have any other questions? I see some new people are joining. I thank everybody for joining and hanging in there. And we are recording, so we can post this later, so you can go back in and actually listen to and analyze it for those that joined late that may feel like they missed some stuff. No questions? Oh, go ahead. I was talking over somebody. And tonight we also, I want to thank, and Lawrence, I'm gonna let you do your intro. We didn't get a chance to do that intro. Tonight we're actually joined with another group. So I know some of our group members are looking like, hey, these are new faces we haven't seen before, but it's actually two groups tonight. Lawrence and I are in a part of Blacks in Technology Slack group, also where I met Watson at. And so we wanted to get together and just do a joint venture on a meetup on topics, such as, cloud native, more so along the lines for information. My trainings in my group are probably a little bit more hands-on, and we can get hands-on as well too, on a joint meetup. But I like to hear feedback from everybody on, like, where are you at in tech? Where are you at right now? Are you all in, building out things in the cloud? Are you security? Are you project manager? Where are you at in this tech landscape? You don't have to all answer at one time.
Hey, Tamika, this is Lawrence. So yeah, thanks for the invite for the joint meetup. And just for reference, I help run a nonprofit group called Code Connector, and we're all about helping people make the transition into tech with a focus on underrepresented minorities and people making a career transition from whatever background they have. Typically in our world, we typically are pushing people in, I don't want to say pushing people, but our knowledge base is traditionally with, web applications, mobile applications, front end, back end, that kind of a world. And there's a variety of other worlds out here with cloud and DevOps that we typically don't get into. And I see that you're, my little local expert on that. So I said, hey, we need to get together somehow. And so you just kind of threw the idea of a joint meetup out there. I was like, yes, bet, win. So happy to be here. As far as myself, I'm a software developer, brand new at FedEx, been there for a year. I do a lot of Java. So my integration with the cloud is like just as much as I need to know. But I think the little touch that I've had is exciting, but there's not like a whole lot of exposure. And we have a whole team called Cloud Dojo that is completely separated from the developers. It's really weird. They're like DBAs, and they just do everything cloud. I know we have some GCP and some Azure and a whole lot of PCF, the Pivotal Cloud Foundry, which is my microservice that my team uses primarily. But they're just so separated, like you don't even deal with them until you have a problem. So just having this integration this time together is awesome. Somebody asked the group is called Code Connector. You can find us online, Slack, social media, all over the place. It's a nonprofit group. It started in Knoxville. I'm more in the Memphis kind of area, but we have a couple of places throughout the country. And like I said, we focus on software, but there's a whole lot more to tech than just building websites. And I don't think we have the knowledge base in my group to share that with people. Like, hey, you may not just want to make yet another website. There's all kind of other stuff. So come on over here, hang out with Tamika and friend. She's my, like I said, she's my resident expert on Linux. If I don't get at least one nugget from her every week, there's been a glitch in the matrix. There's something wrong in the universe. So thanks for the invite.
Right. You're welcome, and thank you for coming out, and thank everybody for coming out. Again, we're free form over here. We're not formal. We're and we talk about everything and we debate, but we also learn one of the biggest takeaways that I took out of what Lawrence just said is like, I think for me, and this is my own personal opinion, I think when we're talking about getting into tech, we get sold that the only way to get into tech is to code, and that's just not it. There's so many avenues in order to get into tech, and I just really want people to understand that, hey, look at tech from a 360 point of view. And then once you look at tech from a 360 point of view, then choose where you want to dive into. And it's also okay to say, I just don't like that, right? Like, I just don't like it, and then make a pivot, right? And I think one of the biggest problems that I see in tech is making the pivot, knowing where can I go next with with the set of skills that I have, so I can make a pivot and still not worry about whether or not if I'm gonna eat or if I'm going to be able to pay my bills. Just really, I wanted to bring that in. Dee's on. She's a co-founder with Women in Linux. I let her give her spiel there.
I just to piggyback on both what you and Lauren said is, in regards to like tech is a journey. For me, I've been like dibbling and dabbling in everything for the last 5 years, and I'm coming full circle right back to infrastructure. But I had to find out what I really wanted to do. I think as kids, I know for me, my mom was an educator, so my path was pretty much set out for me. And she told me I was going to college, but not, what am I going to do at college? Like, what should I major in or any of that? So tech for me was my own personal journey to kind of dive in and say, you know what? I want to go into web development, and to say, you know what? I've given you 90 days of my life. It's not where I want to live at. Like, no, that's not what I want to do. Linux today, I don't want to deal with you today. I'll see you later. Do I know enough to get by? Absolutely. And to play in data centers and to, learn about, different project management methodologies and, working at a tech startup and doing all these things, it's okay. Like, you don't have to be somewhere, and you can gather a whole bunch of skills and create something that works for you. Like, everybody's journey is different, and you don't have to be a programmer, and me and Watson had this conversation before, like being a programmer, like code is art. Like, you really have to be able to dedicate your time to doing really, really great code. Because when I was in there and I was looking at it, I was like, oh my gosh, I was like, this is clunky. I want it to be pretty. I want it to be, I want it to be better than excellent. And it's a craft that you have to continuously hone. So that's just like my little 2 cents. But enjoy the journey and explore.
Appreciate that. Thanks.
You're welcome. And I'm also seeing here that we have a variety of people. So in case I did not give any introductions, we kind of just hopped into it. So I'm gonna give a brief spiel. Tamika Reed, co-founder of Women in Linux. I actually started in tech really when I was a kid, because I wanted a computer, and I thought, because I was, again, I'm my only child, and I was watching the Home Shopper Network, and I was like, they say computers is going to be the thing, so I was like, I gotta get me one of those. And plus I was playing with computers at school, and I thought they were super cool, so I was like, oh, I need to have one. And I went to my dad, and he brought home a Tandy 83. And if you're, and I'm dating myself here, but if your mom was like my mom, don't hook that up to my TV, because it's gonna mess it up. So I never got a chance to play with it. So never got a chance to play with it. So fast forward, moved to Hawaii, and started getting into Cisco networking. And my lab partner was like, hey, this command line is just like Linux. Had no clue what Linux was. And I was like, oh man, I said, I am going to get really good at this. And so he sold me a computer for like $75. And I started playing with Linux, and I started trying to make it look like Windows. And so I went to the bookstore, and from there, I've always, how I learned then is how I learn now. I literally pick up a book, I read it, I take notes, I try it, I fail, I take screenshots of it, I make my own notes from that, and I just keep going. Again, this is pre-YouTube. You would say, why are you doing that? This is pre-YouTube. We didn't have YouTube at that time, so that's my story. So I've been in it. I've been doing Linux administration, architect, building out data centers now. We're going into almost 21 years. So, that is where I am at. That's where I came from. That's my humble beginnings. But I want people to understand, like, it. But the thing that I did leave out of that is I graduated from high school, went to college, partied. I'm from Atlanta, so you party hard. You have fun, and you drop out of school. You have fun, you drop out of school. And then I went back to school, and they said you needed a computer. And I had been away from it. By that time, Microsoft had officially came out with the computer and so forth. You did have Apple, but Microsoft officially came out with their computer. They left WordPerfect, and now you got this Office. And I was scared of the actual screensaver. I didn't know what a mouse was. I was scared of the screensaver. I was like, oh my God. I used to call my ex-husband at work, and I'd be like, the screen went black. What do I do? And he was like, you just move the mouse. And I was like, say what? That's all I got to do. It'll come back. And so I moved the mouse. I said, okay, it's back. I'm just saying, I would call him and be like, I didn't break your computer. It just went black. And he's like, just move the mouse. So I'm giving you that story to say that your journey in tech can take you many different places, but just know that there are different journeys that you're gonna go on, and be comfortable with pivoting and making those things. So I just want people to know that you're not alone in your journey in here in tech. It's a lot of our faces out there. But you also have to talk. You know what I'm saying? You also have to share your knowledge. And so that's why we create these communities, so you can share. I'll leave the floor open for anybody else who wants to share.
You know what really tickles me is that, like, you are like the resident go-to Linux person, but I don't think people hear that you've been like doing it for 20 years. And so when they are studying and they're learning, they're trying to like be at the 20-year level when they just need to start out with day one. And so for me, I'm comfortable at starting at day one. And I know sometimes that frustrates you, but for me, it's just like, okay, I need to go back and refresh. And it's okay to do that as well, to go refresh and take a few little courses and see if anything jogs your memory, because we're always learning. And sometimes, you forget stuff. A lot of stuff that they teach you in day one of class, you're not going to be using 5 years from now, 3 months from now, by the time you finish school and interview for the job, because they ask you the most obscure questions.
And I see your comments in the chat, and we appreciate you all too. But yeah, when it comes down, like tonight, the cloud native talk, why was that important? Well, not just understanding what it is, but when I sit in meetings all day, every day, and I can tell you now, people who are above you don't know what cloud native means. And so they'll come to you, excuse me, and say, hey, we want to be cloud native. And you're like, yeah, we should be cloud native. And not only that, you say you should be cloud native, and you say to yourself, well, what does that really mean? What does that really mean for us? Like in this particular in that particular group, or what does that landscape look like, and how do we get there, right? So the talk was important to have it, so you can have one, not just a reference, but actually have a discussion about it to find out what you think you really understand, right? If the best way to the best way to know that if you know something is to go teach it, right? So if you've never been in my group, you should know by now. I like to call out things, so I'm going to do that now and ask, what is the definition of having a declarative API? You can cheat, you can look it up. You can also ask Watson, and he can fill you in. There he is. He's like, you gonna put people on the spot? Yeah. This how you test people, if you know it or not, right? If you not necessarily if you were paying attention, but I like for people to walk away with, like, if you were sitting there in a room with a bunch of people and they start spouting off stuff, you can like, no, that's absolutely not it. Here you go. And here's where that definition comes from. So that's just things that I do. I give pop quizzes. So I would turn this over to anybody else that wants to share their story or answer that question, and give your takeaways. I see some are programmers and some are AWS, and some people are making transitions. You can tell your story or your journey.
And then if you're more comfortable, we can stop recording, and so we can get everybody on the screen. I know it's still going, but we can just have a